Hello and welcome everyone. This video is directed to plugin developers who would like to collaborate with me on my Onset Detector, because I just open sourced all of the results of my work that was put into the onset detection, which I made a few episodes about lately. And as you can see in the README, I see two essential benefits from this project. First of all, nerdy users can build it as a VST plugin because it sends out MIDI sysax messages of a certain kind when there is an onset in the signal. And you know, if you have this plugin and then you make a plugin that interprets the onsets, you could load it after the plugin and then you can test various onset interpretation methods and have it in separate plugins. That is useful. But it's not that useful for just users who want to make music directly because it's not attached to any interesting process right now. So unlike a transient shaper or something. The more interesting thing that you can do with this project is you can fork it and you can work on it yourself. And if you improve it, you can send a pull request so that I also have an improved onset detector. My vision is that we could just all work together on this so that we all have a great onset detector. Now obviously someone could just download this, improve it and use it all for themselves, and that is probably also going to happen a few times. But you know, there is no modding community in VST plugin cultures a lot so far, like a little bit. Some DAWs have scripting languages and stuff, but plugins, they are rarely improved by multiple unique third-party developers. And I feel like it would be kind of cool if that changed, because if we helped each other like that with a few different kinds of algorithms, then it would give all of us access to incredible resources. And yeah, that is my plan because of that. Let's see if it works out. And now I will show you a little bit of an overview in this video so that you know where everything is, so that you can get started easily. Now, first of all, this is a producer project, so it's very easy to load it up. Now when you go into the source file, the onset detector is being instantiated in the processor. As you can see, if PPD has onset detector, then it includes the onset detector. In the producer, you can go into this menu and then scroll down here to go to the preprocessor definitions tab, where there are a few things that have to do with the onset detector, like has onset detector. When it's being set to 1, then the entire project has an onset detector at all. I added that because I might not use onset detection in some plugins. Obviously for this project it should always be turned on. Then PPD onset debug parameters is the preprocessor definition for whether the onset detector should have a lot of parameters or not. Obviously the goal is to have an onset detector that can do its thing with as few parameters as possible, so that it can be combined with more interesting plugin features as much as possible without cluttering the interface and stuff. So this is how you do that. When it's set to 1, then all of the parameters that you come up with are exposed. When it's set to 0, then that is the front end kind of view into the algorithm. And yeah, you have to keep that in mind when designing new features. PPD onset algo max and algo sum are different algorithms in the onset detection that I showed you in an earlier video as well. And PPD onset algo selects which of these is currently the case. Apparently PPD onset algo sum is the case right now. Okay, so these are the preprocessor definitions that you can use. You can also delete all of them and to just have it a little bit of a more easier time when working on this project, and I will add it back in when you make a pull request. So it doesn't all have to be perfectly my way of doing things. When you make a pull request, I can look at it and convert it myself if needed. But yeah, that is why this says if PPD has onset detector. Okay, so we can see an onset detector object in here, and then if we are in the CPP file and look for the onset detector, then we can see it's instantiated in the constructor. And there are a few parameter callbacks in the constructor as well with the given parameters. As you can see, if PPD onset debug parameters is making sure that some parameters are only used if they exist. Here is the prepare to play method where it is prepared with the sample rate. And here is the point in the code where it is being used with the audio buffer and the MIDI messages. The MIDI messages are given so that it can add the sysex message to the MIDI buffer, of course. Okay, then if you go into the audio folder where there is also something called plugin processor, then that is the actual underlying processor of the main thing that goes on in the plugin. That is how I like to structure things. Like this processor here is for the general stuff, I/O setups and all that. That is just the case in every plugin project. And this inner plugin processor is for the custom stuff that is special to this project, okay? And this just says, okay, there is onset detected false. If there was an onset and there are samples, then put an onset at the first index, because that's where the onset is. And at the end of this block, check for new sysex messages. If the sysex message is an onset message, then set onset detected to true. Now, obviously keep in mind that this is sort of wrong way of writing code. If you had 2 instances of this plugin in your DAW, then it would fall apart because it is a static variable and then it would share the variable with multiple plugin instances. You can fix that if you want, but I don't think it's very important because this whole thing is made for debugging anyway, so you know. Here in the DSP folder and then in Onset, there are all of the classes that have something to do with the onset detection. For example, this is the onset axiom header in which I put all of the default values. This is relevant for the parameters. So as you can see, like which number of bands is the default, minimum values, maximum values. This is all for the parameters. Down here, this is not a parameter, as you can see. It describes the ratio between the decay of the 2 different envelope followers in the onset detector of each band. So yeah, all of these should be tweaked. Like if you find a setting that works better than the setting that I already defined, then you have to tweak these values. And if you add new parameters, then you have to add new static const explorers for the default values of those as well here. And then the actual onset detector header, which has onset core, the core onset detector, which has 2 envelope followers, an onset buffer and a few values, and a resonator. The resonator is a bandpass filter, by the way, and it's being used so that multiple different parts of the spectrum have their own onset detectors. Then there is the onset stronghold class, which I called like that because it looks for how long it should hold back on finding new onsets. And then there is the onset detector struct, which is basically like an array of onset cores so that each of them can have their own frequency on the resonator. And as you can see, this class also has the onset stronghold and a few other values and an onset buffer and a sysex object. The sysex class can be found in the MIDI folder. It's supposed to not be exclusive to this onset detector feature because I want to add more sysex messages to my project at some time. But at the moment, it can exclusively create sysex messages that represent my onset detector output. This is the place where you find the main processing method, by the way. It sets the onset index to -1, and only if at the end of this method it is not -1 anymore, then the process has found an onset, then the stronghold class is being processed, and then we are copying the audio buffer into the onset buffer while also reducing it to mid. Then we rectify that, and then for each band we process the detector by copying from the buffer, resonating and synthesizing the envelope followers. Now here, depending on the preprocessor definition for which algorithm is being used in the sample loop, we do different things. We do want to fill the value of this val variable, and if the algorithm is algomax, then that means that we are looking for the max value. The detector that detects the highest value is the value that is being here, and ppd onset algosum is just summing all of the detector's values to the value and then at the end dividing it by the number of bands to normalize it back. So these are just 2 different approaches to detect onset when you have multiple bands, and I found the second one to work better, but I'm not sure. I'm not very methodical about that. It's just how I felt. So you are very open to also activate this one again and see which kind of benefits that has. And yeah, at the end, some code for the stronghold thingy. And this processing code is basically a wrapper around the other one that makes sure that it works to have only arrays in this whole class and no dynamic arrays like vector. But you don't have to pay attention to this. This does not have to be tweaked. So yeah, my overall goal with this is to have an onset detector that works as good as it can, especially in regard to timing. We could go into any direction with this. Yeah, that's just what I wanted to say today.